The operator inputs the recipe with the percentages of required materials, and the feeders discharge them into the TRM. The TRM starts at maximum speed, heating the batch by means of friction. The temperature of the material rises and its density increases with a consequent release of humidity, which is extracted and removed from the system by means of the filter on the cover. The water vapour then condenses in the decantation units before the vacuum pump. The material in the TRM condenses and becomes increasingly dry, therefore slightly reducing in volume, while it continues to be heated at high speed. In this phase, its temperature rises constantly. When the temperature of 155 degrees centigrade is reached, the vacuum pump stops and the TRM continues to heat the material at maximum speed. The residual humidity passes from an initial 10% to the final value of 0.1%. The temperature continues to increase, and the polymer PP rapidly melts until it reaches a semi-liquid state and binds with the wood fibers. At this point, the temperature in the TRM will have reached 170 degrees centigrade, indicating that the PP has attained a fully molten state and the wood flour has been coated. The discharge point of the TRM opens immediately. The compound is poured entirely into the HEC and is distributed by means of the agitator across the entire exchange surface, by means of centrifugation. The inside of the HEC is cooled with circulating cold water in a double jacket. In this way, all surfaces are cooled in a uniform manner, including the tank, the sides, and the cover. The agitator inside the HEC has a geometrical design that keeps the material in contact with the cooled surfaces and gives a more efficient heat exchange. The temperature of the homogeneous mixture inside the HEC drops from 170 degrees centigrade to 80 or 90 degrees centigrade. At this point, it begins to bind by effect of the action of the agitator. Subsequently, it passes over to lump breaker devices, each fitted with 3 cutter blades revolving at high speed. It's thus reduced into small, irregular granules not exceeding the size of 10 millimeters and with a very low level of residual humidity, typically below 0.5%. The granules discharged by the HEC are then ready to pass on to the subsequent processing phases, including granulation, or, for example, direct extrusion of the profile.